Angles are everywhere, especially in places like nature. Today we're diving into two key types, complementary angles, which make 90 degrees, and supplementary angles, which make 180 degrees. In this lesson, I'm going to teach you about complementary and supplementary angles. We will go over important vocabulary like angle, vertex, and adjacent angles, and I will explain what makes angles complementary or supplementary. We will go over the solving process too. Then I'll walk you through an original problem and we'll solve both regular problems and one nature word problem together using our newfound knowledge. Before we get into it, if you want to skip and go straight to the practice problems, you must leave with the knowledge that complementary angles sum to 90 degrees and supplementary angles sum to 180 degrees. I highly recommend you stay for the entire video, so without further ado, let's go. Let's go over some essential vocabulary. Our first vocab words go over angles, rays, and vertex. Let's first think about a ray. Here I drew a ray for you. A ray is like a line that starts at one point and goes on forever in just one direction. So imagine drawing a line with your pencil that begins at one spot of the paper, right here, and keeps going straight without stopping. So it's keeping on going. Now when you have two rays, one ray over here and one ray over here, and they start from the same point right here, this is called the vertex. You can think of the vertex like the corner where two streets meet, or the tip of an open book where the pages come together. The angle right here, is the space or opening between these two rays. It shows how much the rays are spread apart from each other. If the rays are close together, and in this problem you can see that they are relatively close together. If the rays are close together, the angle is small and sharp. If the rays spread wide apart, the angle is big and open. We measure the size of an angle in degrees. Degrees tell us exactly how wide or narrow the angle is. For example, a small angle might be just a few degrees, while a big angle could be close to 180 degrees, which looks like a straight line. To sum it up, an angle is made by two rays that share the same starting point called the vertex. The angle is the space between the two rays, and we measure the angle in degrees to know how open or closed it is. So in this example, we can see that two rays meet at vertex M, and then that this space is the angle measure. So this is a relatively small angle, so we can say that it's below 90 degrees or it's an acute angle. Our next vocabulary term is adjacent angles. Adjacent angles are pairs of angles that sit right next to each other. They share the same vertex. That's the point where the two rays meet. They can also be line segments, and they also share one side, or ray. Imagine two slices of pizza, side by side. They don't overlap, but they touch at the crust, which is like their common side. This next to each other placement is what makes them adjacent. So in this example, we can see that angles CAD and DAB are adjacent because they're right next to each other and they share the same side. So A degrees and B degrees are right next to each other. They are adjacent angles. Let's talk about complementary angles. Think of like a perfect corner, like the edge of your math notebook or the corner of your whiteboard. That's a 90-degree angle. Complementary angles are two angles whose measures add up to exactly 90 degrees. These angles don't have to be connected or touching, they just need to add up to make that perfect right angle together. And if they are adjacent, meaning that they're next to each other and share a side, they actually form a right angle when combined. In this example, we can see that we have two adjacent angles and that sum up to 45 plus 45, which is 90. We can call them complementary. A good way to remember this is complementary equals corner. Both start with a C, and they add up to make a right angle corner. We can see that we have PQR as a right angle corner. So let's step this out. In this example, we see the two angles that each measure 45 degrees, as I said before. It's Since they share a common side and their angles measure and add up to exactly 90 degrees, they are called complementary angles. Together they form a right angle, which is a key indicator of a complementary pair. So right here we have angle PQS plus angle SQR, and we don't know if they're complementary or not. So we're going to add it to see. We are given that angle PQS is 45 degrees, and angle SQR is 45 degrees as well. So substituting that into this equation we have right here, 45 degrees plus 45 degrees equals 90 degrees. 90 degrees makes a complementary pair. This is very simple, and all you do is to find out if the angles are complementary is simply sum the angles. And that means that PQ is perpendicular to QR. Because whenever two lines meet to form a 90-degree angle, they are perpendicular by definition. Now, note that if two angles add up to 90 degrees, they are only called complementary. They are not perpendicular, unless they are adjacent, meaning they share a side and a vertex. So if angle PQS and angle SQR are not touching, but still add to 90 degrees, they are complementary. But you can't exactly say that the lines are perpendicular. To say something like PQ is perpendicular to QR, the angles must be adjacent and form a right angle at the corner. In this example, we can see that angle PQS and angle SQR are separate, so they are only complementary and not perpendicular, because they are not adjacent and do not share a side or a vertex. Let's talk about supplementary angles. I want you to think of a straight path, like the edge of a ruler or the top of your desk. That's a 180-degree angle, a perfect straight line. Supplementary angles are two angles whose measures add up to exactly 180 degrees. In this example, we see that 135 plus 45 degrees, so MPR plus RPS equals 180 degrees. We'll go over that in the next slide. So these angles don't have to be touching or connected, they just need to come together or make that perfect straight line when you add their measures. And if they are adjacent, meaning they sit next to each other and share a side, then together they form a straight angle, a full half turn if you think about it in a circle. A good way to remember it is that supplementary equals straight, and both start with an S, and together they make a straight line angle, 180 degrees. So as I said before, in this angle we see two angles. In this example we see two angles, one measuring 45 degrees and the other measuring 135 degrees. MPR is measuring 135 degrees and RPS is measuring 45 degrees. Since they add up to exactly 180 degrees, they are called supplementary angles. So we want to know what angle MPR plus angle RPS equals to. We don't know if now that if they're at exactly a complementary angle or a supplementary angle or neither. So we find that angle MPR is equal to 135 degrees and angle RPS is equal to 45 degrees. Now substituting those things into this equation, we find that 135 degrees plus 45 degrees equals 180 degrees. Now what if the angles are not necessarily adjacent or next to each other? Well then, note that the two angles don't have to be connected or form a straight line side by side. As long as their measures add to 180 degrees, they are still considered supplementary. However, you cannot call these angles a straight line because they are not a half turn, they are not adjacent to each other. So like complementary angles, if they are not adjacent, you cannot call them a straight line. You can call them supplementary though. In this case, angle MPR and angle RPS are not together. So we can't call them a straight line, but we can call them supplementary pair. In case the definitions were too confusing and much for you, I'm going to be going over the process or steps in full detail on how to know if you have complementary or supplementary angles. Once you know if a pair of angles are complementary or supplementary, you can solve anything related to it. So once again, this is a review and a detailed process for you to follow along. Step 1. Look at the two angles that you have and find their measures, the numbers in degrees. So we have A degrees and B degrees right here. We see that our two angles are adjacent to each other. Now we found that their measures are angle A, we're calling this angle A, and angle B. Angle A is 80 degrees and angle B is 10 degrees. Step 2 is to add the two angle measures together. We found that angle A is 80 degrees and angle B is 10 degrees. So what's angle A plus angle B? We can substitute angle A and angle B and find that 80 degrees plus 10 degrees equals 90 degrees. So our step 3 is if the sum is 90 degrees, then the angles are complementary. And if the sum is 180 degrees, the angles are supplementary. If the sum is not 90 or 180 degrees, they are neither. In this case, we can see that angle A plus angle B is equal to 90 degrees. So this is a complementary pair. If the problem only gives you one angle and asks you to find the other, here's what you do. First, figure out whether the angles are supposed to be complementary, adding to 90 degrees, or supplementary, adding to 180 degrees. The problem might tell you directly, or you might have to figure it out based on clues. Once you know that, take the total, either 90 or 180, and subtract the angle you're given. This will help you find the missing angle. In this case, we have 8 degrees and 10 degrees, and we are given that this is a complementary pair. So we don't know what 8 degrees is, so we're just going to call that angle A. Angle A, we don't know. It's a question mark. Angle B, we found that we're going to call this 10 degree angle angle B, and this is 10 degrees. So we know that angle A plus angle B is 90 degrees due to the fact that they said that this is a complementary pair. So we can substitute angle B into this equation, and now we have that angle A plus 10 degrees equals 90 degrees. We can subtract 10 degrees on both sides, so angle A plus 10 minus 10 equals angle A, and angle A equals 90 degrees minus 10 degrees. So we now know that angle A is 80 degrees. All you do is the missing angle equals the total minus the given angle. In this case, the total was 90 degrees, and the given angle was 10 degrees. So we found that the missing angle is 80 degrees. How to check your work? You can basically add 80 degrees back into the previous equation. So 80 degrees plus 10 degrees equals 90 degrees. We know that this is a complementary pair. You can do the same for a supplementary pair. Same process and same steps. Now I mentioned that the problem might not give or tell you directly if it is supplementary or complementary. So you need to check for visual clues. If the angles form a corner, like a perfect L shape, that's a clue that they are complementary. If the angles form a straight line or sit side by side on a line, that's a clue that they are supplementary. Pay attention to the numbers. If the two angles are small and seem to be adding up to close to 90 degrees, they might be complementary. If they are larger and seem close to 180 degrees together, they might be supplementary. You can also read what the problem is asking. Sometimes it says these two angles form a right angle. That means that they're complementary. If it says these angles make a straight angle or form a straight line, this means that they are supplementary. We looked at the visual clues and we saw that this pair was complementary. So that's the full process. If you want to go back and play the video for that detailed process again, you can. But right now we're going into examples and practice problems. Our practice problem number 1. One angle measures 38 degrees. The angles are complementary. What is the measure of the missing angle? So here we have a diagram. We knew from that problem that one of the angles measures 38 degrees. We have that right here. Now we don't know what the other angle measures, but we do know that these are complementary. So we drew it such as. If we wanted to further algebraically express this, we can say that this is angle A. Angle A, we really don't know what it is. We can say that this is angle B, and angle B is 38 degrees. Angle A plus angle B equals 90 degrees due to the fact that the problem said that they were complementary. As we know before, complementary angles sum to 90 degrees. Now we can say that angle A, substituting this, we can say that angle A plus 38 degrees equals 90 degrees. We knew that angle B equals 38 degrees. Now angle A minus 38 degrees equals 90 degrees minus 30 degrees. We basically subtracted 38 degrees from both sides. And now we got that angle A equals 42 degrees. Pardon me, angle A equals 52 degrees. We found that 52 plus 38 equals 90, which is a complementary pair. Once again, it equals 52 degrees and not 42 degrees. And we can check that by checking our work. 42 plus 38 equals 80. 52 plus 38 equals 90. So once again, so angle A is question mark degrees, angle B is 38 degrees. Angle A plus angle B is 90 degrees, and angle A plus 30 degrees equals 90 degrees. Angle A minus 30 degrees equals 90 degrees minus 30 degrees. So angle A equals 52 degrees. Practice problem number 2. One angle measures 125 degrees. The angles are supplementary. What is the measure of the missing angle? So we drew our diagram right here, and we found that 125 degrees and question mark degrees. We drew it like a straight line because they said in the problem that this was supplementary. Angle B equals 125 degrees. Angle A equals question mark degrees. Angle A plus angle B equals 180 degrees. So angle A plus 125 degrees equals 180 degrees. We saw that by substituting angle B's value in that equation. So subtracting 125 degrees on both sides, angle A minus 125 degrees equals 180 degrees minus 125 degrees. So angle A equals 55 degrees. Now let's see if this is right or wrong. We can check our work back into the equation. So 125 degrees plus 55 degrees equals 180 degrees. We know that this is right. Our practice problem 3 is kind of naturey and like the theme of the slide, and a leaf folds at a 70-degree angle. It forms a complementary angle with the stem. So what is the measure of the other angle? We drew our problem right here. We found that this is a right angle, and we drew our 70-degree angle and our question mark angle. So we don't know what angle A is equal to. So we're going to call this angle A. And angle B is 70 degrees. We're calling this angle B. Now we know the problem stated that angle A plus angle B is 90 degrees because it said it was complementary. We can substitute angle B's value into the equation and say that angle A plus 70 degrees equals 90 degrees. So subtracting 70 degrees from both sides, we found that angle A minus 70 degrees equals 90 degrees minus 70 degrees. Angle A equals 20 degrees. Thank you for listening, and I really hope you understood what supplementary and complementary angles are. Thank you.